This is House Planning Help episode 320. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Antoine from Kithurst Homes, and we're going to be looking at the efficient use of timber. Things like I-joists, you might hear that term bounded around. What exactly are they? Why do they work so well? And how are we embracing modern technology to cut with precision? So all sorts of benefits, speed, reducing wastage. We'll hear all about it. And a big thank you to Jay Cottrell from Passive House Homes for introducing me here. She said, Antoine is a really interesting guy. You need to go and have a chat, which is what we're doing. Milestones have a habit of creeping up on you, don't they? And this session marks a decade of me doing this podcast. I really can't believe it. It's been a wonderful learning journey, and I'm so grateful to everyone who's spared me time to talk through things, share their knowledge. I've attempted to pass it on to you as well. And I think I knew even on day one that there's just so much in this topic, and always we're trying to look ahead. What else could we be doing? That I would never get bored, and that's certainly the case. So I intend to keep on going. Initially, I had my sights set on building my own house, but that's now 4 years ago since it was complete. So I'd love to get involved in another development. You probably know I've said this before, and I will keep on trying. So hopefully we can get under the skin of another project here on the podcast. For obvious reasons, over the last couple of years at least, a lot of the interviews have been remote interviews, and I feel that's fantastic. It certainly makes a lot of sense when you're trying to interview people over distance, but I do enjoy getting out and about, and I'm certainly trying to do that more at the moment, particularly if there's a building to see, because that's not quite the same on Zoom. So I got the opportunity to go and check out the cutting facility at Kithurst Homes. And Jay had said this was impressive. So let me paint a little picture. You've got one building that is brimming with timber, the I-joists, the glulam beams, all the sorts of things that we're going to be hearing about. And then the other building, again, a warehouse, but just eerily empty. It's because all that timber in the other building is going to be passing through. And there's a yellow and red, quite small machine in many respects that's going to be doing all the work. It's got these blue rollers on either side so that the timber can slide in and out under the control of the machine. And it's not in action today, which is how I'm able to get some of Antoine's time. So I started by asking Antoine to tell me a little bit about his background.
Study physics, work in construction as a troubleshooter for many years, and always loved timber and forestry. And making work into timber industry, for me, using engineering timber make complete sense because you use way less timber. Building out of timber is not as eco-friendly as people want to make it look like. It is not carbon neutral. It's no building which are carbon neutral anyway. But it's important to use it properly. It's a fantastic material, and you have to use it properly.
You've mentioned timber, which is certainly how we're going to centre this conversation today. Then, so what timber do you use in your day-to-day work here?
We use engineering timber, so LVL, laminated veneer lumber, very rarely CLT, cross-laminated timber. We use glulam, and we rarely use softwood. If we use a softwood, it'll be a KVH, which is an engineering softwood too.
And what material is this? Is it all one type of timber?
Laminated veneer timber is like a plywood on steroid. KVH is finger jointed timber. Cross-laminated, well, is a cross-lamination of timber a different way. And glulam is softwood glued together.
And is this a mixture of trees or what type?
Normally you use the same tree, well, the same species at least. And it depends on what you want to do and what strengths and the tensile strengths and what you're using it for.
Now, you've got an amazing kit here at your workshop. So maybe you could paint a bit of a picture. How did you get to this stage to have this amazing cutting ability?
So we used to cut frame by hand like everybody. We had a big chop saw, a digital compound system where we used to cut them to usable lengths for the part we wanted. If we need an angle, a compound angle or a bevel, put to that angle, cut every single part we had that, and move the saw to another angle and cut all the parts. So it took us, for a 200 square meter, say, a house, it used to take us 2.5 weeks to get everything proper, number, packed, everything. And when you cut them regularly, you say, you got human error. It's quite repetitive, and it's a bit of a nightmare. As much as I like cutting timber, so we decided to go into more automated system. But finding the right machine was quite tricky. Some just cut straight, some just cut an angle. Not many machines do what I wanted, and we went to Hundiger, which is a fantastic machine with 5 axis so it can do so many different cuts, and you can put a milling on top. It can do so many things. So we went to that, and that same 200 square meter frame, the first time we cut it, not the same one that we used to do, but because all our projects are a bit different, but the same size, we cut it in 3 hours instead of 2.5 weeks. It took us 2.5 weeks to pack it together because we find ourselves with a mountain of timber. But the wastage is really, really low. It's less than 3%. It's all marked, it's all number, and cut properly and to size. So it made our life really easy.
I was going to ask about marking, so it even does that.
Yeah, it does mark where the stud meet, where the timber meet. It marks the name, the pack number, or the wall, or the group, whatever you want to call it.
Let's rewind to how this would start then. So you can't just expect the machine to build your house without giving it some information. So where does it start? Is it the architect says, I would like to build this building?
So we got 2 type of different customer. We got customer like HPH320, fantastic company. We do passive house and use timber and natural product. They do all the frame design with the engineering, and they send us a BVX file, which is a machine language file, which the saw can understand and cut. 80% or 90% of the people who come to us, we do that for them. So we get the drawing, is an architect who want to build like this. Quite a lot of developer want to build or got 10 houses to build to passive house standard or very eco-friendly or whatever. So to fill that market, tick the box, they come to us. We take the drawing and we transfer them into our system, which is a CAD-work, which is a timber and steel designing software really made for the timber industry or the steel industry. And we can get your DWG drawing. Every architect can do that. Or sometimes it's a hand drawing, and we transform it into a 3D, because if you think about it, a piece of timber is 3D, it's not 2D. So we need to tell the saw that piece of timber is X, is 150 mil wide, is 250 mil long, so we talk in X, Y, Z, so 3D, and convert that in number and everything into the saw, and the saw will give us the right piece at the end.
Now, I'm sure it will need to know what's going in. So is that changing as well, what you're putting through the saw?
Yes, the saw, every time we send in information, we tell it for which part is cut, of which timber is cut. So if a joist is cut of an eye joist, a stud can be cut of a glulam, or a post can be cut of glulam or cavage. So we need to tell you which one is which one, and he do his life, he recognize and he measure exactly the geometry of the timber. And if the timber doesn't respect the geometry, he will tell you.
The machine will just say, no, something's wrong.
Yeah, he's very German for that. He's very square.
And how do you make sure that you're feeding it efficiently, or is that all sorted, that you're actually working an hour or so down the line, that you've got all the timber going in?
We know, so we program our software for the machine, our line, and we got what we call a picking list. So we know it's going to consume that amount of eye joist, that amount of LVL, that amount of glulam, and we put them in order by size to make our life easier, and just fit it to the machine, and that's it.
So an eye joist, what length would that arrive here at your
13
factory?
meter.
30 meter. And then
13. How
many meters would you need on? Let's stick with our 200 meter square building.
Well, it depends. It's around 500, 600, 800 meter, a kilometer. of I-joist. It really depends on the geometry, the square meters. It really depends on the geometry of the roof. Roof have a tendency to eat a lot of timber, plus the flooring. So it's an average of 1.5 kilometer of I-joist for a big house.
PH15 is one that I know well, having seen a project in Buckinghamshire, the whole thing just popping in every week to see the progress. So that has I-beams going through the roof as well. Is that a common approach?
It's not a common approach. It's an approach we do for years. PH15 developed a similar or different system years ago too. In this country, not many of company work with I-joist. Timber frame is more stick, what we call in North America stick frame, so 2 by or 47 by 100, whatever you want to call it. And here in the UK, 140 is the king size. Everything is on an insulated wall is around 140 thick by 47 by 140 stud.
So is the I-joist one of the most efficient pieces, or does it not work like that because you need other different pieces to interact with it?
So if we were going into a stud work in softwood, I can build 40 to 60% more houses with the same amount of primary wood. Yes. And that's a big difference.
That's a big difference.
So I use way less timber than the main house, and I got less cold bridge because of the size and geometry of the I-joist.
And when it's coming out the other side, you mentioned before about all your timber piling up. So what happens once it's come through? Well, maybe what happens as it goes through, first of all?
Well, it got cut, it got marked. Each company, we normally pack them by wall. Some company pack them by what they call pack 1, pack 2, pack 3, and that can be all the sole plate, for example, first, and after all the stud work for that south wall or whatever. So all those are packed together. We use steel band to pack because you can recycle steel band. You can't recycle plastic banding. Put them on bearer, and they are stacked and ready to be transported in curtain side truck because we don't use plastic on our packaging. We are against plastic. Plastic is killing the world faster than greenhouse gas, so we have to be careful.
Yeah, I do think some people are very slow to respond to finding other packaging methods, but yeah, good on you. That's what we like to hear. And what about your team to make this happen? You mentioned your 3 hours for this house to go through. So how many projects do you have, and how do you manage the team of people?
We work on flexi hours. We schedule the work as they come. So first come, first serve. So when we got all the final drawings signed off, we transfer it into BVX and we schedule it to be cut. But we have to talk to people on site, so they either the builder owner or the developer or the architect or specifier, whoever is our customer. They give us a date of delivery and we deliver that date.
So it arrives on site. Is that out of your hands at that point?
It arrives on site, is out of our hand if it's cut for somebody else. If it's cut for us, we never send a frame without training. So if other company, PH15, for example, do their own training, we do our own training. So one of us will go on site and explain, or they come, if they're local or they prefer, they come here and they'll assemble a wall, get insulation, play with the material, try to understand how we do it, and they figure out very quickly. And normally, I have to say 99% they're super happy because they don't have to take a tape measure or anything. Everything is marked. They just have to bang it together, and it works extremely well. We supply everything, so the fixing, the screw, the staple, the membrane, the plywood, everything is supplied, because we engineer everything and everything is provable.
It's a lovely, clean way of building. So what skills would you say you need to, if you are on the receiving end and wanting to build, what level do you need to be at and what do you need to be aware of?
What you have, it's a good place and prepare your groundwork and everything. But skill-wise, if you got common sense, I know it's hard to find those days, but if you got common sense and you know how to use a screw gun, and you got a good quality screw gun, you can build a house by yourself quite happily, or with a couple of people to help. Or the parts are not that heavy by itself. A night joist, because it's so much less timber, is not that heavy. If we go into big glue lamp for a ridge beam or lintel, they become heavier, but it's always manageable. And you can use a crane when it's a full wall we send you. When it's a full wall system, the nips, you have to have a good team of carpenter, because that is a completely different thing. Is an erection of full wall and stuff like this. So it's a bit different trade. But flat pack is we got people who put them together. They're very happy. They're good DIYer, and because everything is marked, we just tell them. They come with drawing, assembly drawing, so they know the dimension. They know what the diagonal is for the wall, so they put it together and it works. And if they got a problem, we're a phone call away.
Just going back to the efficiency side of things, why do you think construction is so slow to change? It would seem very obvious from what you're doing here that this is a good path.
In this country, we're 25, 30 years behind everybody, because the construction in this country is driven by the big guy, so the big house builder. And they don't want to change because they know extremely well what they do. They do it extremely efficiently for what they want. It doesn't mean that it's good quality. It means that they're making a lot of money always, and they know that it's predictable, and they love that. Plus, don't want to talk politics, but most of them are the one who pays the bill for the poor. So they all been at school together. So if they don't change, nothing will change.
Now, I know a lot of those major developers, they're sometimes a hybrid of masonry and timber. But right at the start of this conversation, you mentioned you've got to be careful with timber that it is sustainable. So what checks are in your process? I mean, presumably you've got people that you lean on now that you trust, but how do you size up where the timber's coming from and that it's manageable?
So all our timber come from 2 or 3 manufacturers. Stico, a German manufacturer, is one of them, because we use the insulation, we use rigid wood fiber, we use blown wood fiber, or matte wood fiber. The I-joist and the LVL, we know they're all PFC, PUFA, all the German regulation, all the European regulation, and we know they are people who use timber properly. They know wastage. They use everything on a tree. That everything is shredded to make insulation, laminated to do the LVL and the I-joist. They do the insulation with using copy things. So it is well documented and signed on for that kind of thing, and that we buy from them. We don't buy from whoever come and say, do you want some timber? We don't use exotic timber. We try to always use timber that we find in North Europe because it's the best climate for that. We work a bit with oak from regular system, from English oak or French oak, because you don't really have much English oak those days. But all our timber are PFC and F certified and everything.
Can you do any cutting if people bring timber to you, or that's not something you like to get involved?
No, we don't get involved with that. It become a very tricky part, because the timber have to be such a good quality and so regularized for the saw to recognize what it is.
You mentioned you get these I-beams in, they're pre-formed and so forth. So what has it gone through to turn it into the I-beam first of all?
So an I-beam is basically an outboard web with 2 LVL as flange. So what they do is they take imagine a tree, put a spike on each side of the tree, and you're going to take all the ring, you're going to unfold them, put them at 90 degrees to each other, or lengthwise, press them in a wet system and dry them so it become like a plywood. And the machine cut them to size, put a groove and insert this hardboard and push it together and glue them. So you got an I-beam, or you got just that primary thing, which is LVL, the laminated veneer lumber, cut to size. So that is engineered, so it stayed along the line of when they build it, they test it after, before, so they know it's perfect for engineering because they react always the same. Contrary to softwood, which doesn't react always the same. It can have a defect in it and everything. This is proven that it doesn't have defect. Well, 99%. Our machine recognize that and know that if it's a 300 high joist, it'll be 300 all the way down. It won't be 300 on one side and 320 on the other side. And it'll be 39 mil thick or 45 mil wide. And it's the regularity of the timber make it really easy to work with and predictable. And predictable is a good thing in engineering.
And what gives it the strength then?
Well, the strength is done due to the lamination of the timber. Hardboard is incredibly solid, and the flange is like really a plywood on steroids, so it's quite thick. Not that thick, but it is quite thick, and is again predictable. We know how a timber will react on strains, tensile strengths, bending, modulus, shear, and everything. So we can predict that all along it, and it's always the same.
Now, just getting back to your process here, you've got a very sophisticated bit of kit. Is that the end of the process? Are you ever tempted by anything else? Is there anything it doesn't do that you like to do? Or?
Well, we got a CNC machine to do the gusset, which are the web stiffener, if you want to call it like this. We got that, so maybe we'll invest later on in another CNC to cut a bigger panel. At the moment when we send a kit outside, people on site have to cut by hand the board material, so the OSB or the panel vent, the vapor block. So we're looking at cutting it here because, again, the beauty of our system is when you send it on site, you don't need a skip for a ton of offcut because everything is cut. You don't need to recut anything. And that's a big saving. Well, most of our customers, the first thing they say is it's so lovely not to have a skip on site. For example, roof are often the thing which is a bit tricky. People have a tendency to do a couple of tries so that it weighs 2 or 3 lengths. You don't have to have that. None of that is done with our system. Everything fit.
Is there anything else we haven't talked about that we should mention as part of what you're doing here?
We only use natural material. That's our ethos. If it's not compostable or recyclable, we don't use it. So we don't use any PU or polystyrene foam. We don't use plastic, and we try to preserve as much as possible the environment. That's the only thing.
Well, that's fantastic, and I'm sure that's why PH15 love working with you as well. You're exactly the same ethos.
Yeah.
Well, Antoine, it's been fantastic to hear a bit more about the process and to see it firsthand, so thank you very much.
Thank you for coming, and you're welcome anytime back.
Head online to take a look at the show notes that accompany this session, houseplanninghelp.com/320, where you can review the main information in our summary or have a look at some of the photos of that magnificent cutting machine. If you've got a comment or you'd like to ask a question, you can do that within the show notes or on social media. We'll have links to all our various social media outposts. We'll link you to Kithurst Homes. And one other thing, actually, if you're one of our hub members, don't forget that we've got a full in-depth video case study of Buckinghamshire Passive House. And that's using the PH15 system, which is still, I love the way how it ties everything together and Jay's expertise as well. So altogether there, we'll put a link in for that as well. houseplanninghelp.com/320. My call to action on our 320th episode, 10 years in, is please review us on whatever app you're listening to us from. Like a couple of people have done, I did Charlie Swan 23. Both of these short, and I think that's fine. I don't need to take a lot of your day, just some sort of review that helps people. Excellent series. I will probably listen to them all. Thank you very much. And frankly, 9999, essential listening for anyone considering an eco self-build. If you can leave us a review, we'd love you forever. Next time, Paul Cianilio, refurbishment lead at the National Energy Foundation, is my guest. When energy prices keep going up and up and up, is there anything you can do to stay in control? And perhaps what we're hinting to here is you really do need to embark on a whole house retrofit. More on that next time. Thank you very much for listening. The House Planning Help podcast is produced by Regen Media, content that matters.